All right, let's check out these last two examples here. Example 17. Now, this one is a great problem for finding end behavior. It's really easy to see end behavior because you're just looking at, again, you're just looking at this first term. This even degree here means that your ends are going to go the same direction. They're either both going to go up or they're both going to go down. The way you tell the difference is the coefficient right here. Since it's a positive number, they're going to both go up. Okay, so that's what our end behavior looks like on this problem. So end behavior is easy in what we call standard form. However, to be able to find our zeros, we need to write it in factored form. Okay, so we're going to actually take this and factor out our greatest common factor, which is an x squared here. And I'm left with a trinomial of x squared minus 2x minus 8 right there. Okay, now we're going to factor one more step because it's still not quite linear factors. We want to try and find the two numbers that multiply to -8, but that add to -2. So our first terms as well have to multiply to this x squared. If I put in a -4 and a +2, that way when you do your 4 multiplications, you get your x squared, you got a 2x minus 4x. That'll give you that -2x. And then you got a -8 right there. So we love this. We call it factored form right here. This gives us our zeros. So we've actually got 1, 2, 3 zeros here. Our first zero is just 0. If x is 0, x squared, 0 squared is also 0. It has multiplicity. Remember, multiplicity is just your degree of that 0. So it has multiplicity 2, which means it bounces at that 0. Our picture is going to touch that point and then bounce back to wherever it came from. All right, for this one, our 0 right here is a +4. 4 minus 4 is 0. We have multiplicity of what we call 1 right there, which means that that's an odd number it's going to cross. And this also at -2 has multiplicity of 1, so it'll cross our x-axis. All right, so you graph 3 things. I always graph the zeros first. So we're going to put down this 0 right here is a 0, 4, 1. I guess we can just mark this down. 4 is a 0, and -2 is a 0. All right, so there's our 3 zeros right there. We're also going to graph our end behavior. Remember, we talked about that earlier. Since it's an even degree, they're both going to go the same directions, positive coefficient, so it's going to go up over here and go up over here. Now, I usually just work left to right, and I kind of look at each of these zeros and figure out, does it cross or does it bounce? So right here, this is my -2 0. Notice how with multiplicity of 1, it's going to cross. So it's going to go down, cross into the negatives down here. Then I look at my next 0, 0. Notice right there, that has multiplicity of 2, which means when it hits this one, it's going to bounce right back. And then this 4, this 0, 4 right here, it has multiplicity 1, so it'll bounce. Or it won't bounce, it'll cross right through and go through like that. So that's what they mean about with all the multiplicities. Okay. All right, last example. This time they're going to kind of describe the picture. We could draw it, but they're really going to want us to write the polynomial function in standard form. Now, note that you're going to first have to start off with writing it in factored form because they tell you your zeros. Okay, so we're going to work backwards. If they tell us our zeros, we're going to write our factors. That would give us a 0. So here's our function right here. F of x is equal to, there's a 0 at -6. Okay, so let's just look at this -2. If there's a 0 at -2, remember that came from the factor of x plus 2 because we want it to go to 0. So -2 plus 2. So if we have a 0 at -6, we want an x plus 6 right there. That way, when we plug in our -6, we get a 0. Okay, so this would be our, if -6 is a 0, x plus 6, the opposite operation is our factor. It has multiplicity 2. That means we're going to write a little 2 right there. And another factor is +2. So that one we're going to subtract it. We're going to do x subtract 2. That way, when you plug in 2, 2 subtract 2 is 0. It has multiplicity of 1. All right, so this is written in factored form. They want it in standard form right here. So what we're going to do is just multiply everything out. So here's what I would kind of remind myself. This is really just x plus 6 times itself. That square just means I've got another x plus 6, and then I'm going to times it by x minus 2 right there. So all three of those get multiplied together. So we are going to start off with, just do 2 at a time. Let's go ahead and do these 2 at a time right here. So we're going to do x plus 6 times x plus 6. Again, 4 multiplications. So x times x gives us an x squared. X times 6 is 6x. Another 6x. And 6 times 6 is 36. Okay, so then after we simplify this, we'll simplify it. Then we need to multiply it by, oh, it's a minus, by our x minus, eraser. Then we'll multiply it by our x minus 2 right there. Okay, but we're going to combine some of those like terms. Let's come up here. You're going to do this. So I have in this function, I've got my x squared. 6x plus 6x is the 12x plus 36. And we'll multiply that by our x minus 2. All right, now let's go ahead and multiply again. Now we've got to do 6 multiplications. We're going to distribute our x squared to both terms. So I've got x to the third minus 2x squared. Then we'll distribute this 12x to both terms. So plus 12x squared minus 24x. Then we'll distribute our 36 to both terms. So we have a plus 36x. And then 36 times negative 2 is a negative 72. Okay, again, just clean it up. You're actually done, but we're going to clean it up because we've got some like terms. There's a couple of x squareds there. There's a couple of x's there. So our function is going to be f of x equals, I just have the 1x to the third right there. Negative 2x plus 12x, or 12 minus 2, is going to be a 10x squared. Negative 24x plus 36, or 36 minus 24 is 12x right there, and then minus 72. That's going to give us our nice little polynomial in standard form. All right, good luck on the homework.